Assalamu alaikum viewers, I am Farrukh Nadeem, here today with a new tutorial and a new exercise. Today's exercise is special because it was requested by one of our dear friends who asked for guidance so that he can perform this task. His question was, what is the method to import any 3D file such as an STL or OBJ file or any other file into Aspire so that we can work on it? It's very easy. You can do it easily. First of all, you need to know the size of the canvas or piece you want to work on. Now, the size of the canvas in the file I want to import is 510 by 602 by 25. That is, it has a width of 510 millimeters. It has a height of 602 millimeters and a thickness of 25 millimeters. I'm going to file here. While staying in millimeters, I will enter these values. I have entered the values. And after that all these settings are already set. You are familiar with them. I clicked OK. After clicking OK, the very first thing to do since we are importing a file is that our source is an external model. You need to go to File, then Import, and here you will find Import Component or 3D Model Import Component. When you click on T Model, you have to select your relevant model here. For example, we have the 2023 3D object. You need to import this. As soon as you import it, the import will take a little processing time. It will reach 99%, and after it hits 100%, the model will start appearing on your screen. Look at this. This is a 3D carving design. As soon as this file appears in front of you, on your left side, you'll see the orientation. A dialog for the 3D model will also appear. From a modeling point of view, the very first thing is the initial orientation. Whether you want to place the imported model on the top, it has to be kept on the right. As you click on it, the changes will be reflected on your model accordingly. See, now it's on the bottom, then on the left, on the back, and now I'm bringing it to the top. Because this design is made on the top. This design was basically made in CAD CAM. After creating it in CAD CAM, it was exported from there. The direct CAD CAM file can also be imported into this, or to keep it in a universal source, it was exported from there as an STL file. And now we are importing this STL file here again. Rotation about the Z axis, meaning which axis it should rotate on. Let's keep it at 0 for now. Its initial rotation will be from 1. The model size is the most important thing. These are things related to its rotation. This is the model size of the model we imported into it. This is its size. Look, this is its height. The design, the model that was imported, its height is 10 millimeters. On the x-axis, its value is 408.5 millimeters. And on the y-axis, its value is 504.46 millimeters. The units are in millimeters. The very first thing you should do is select center of model. As soon as you select center of model, any slight misalignment or offset to the right or left will be corrected. Many times, due to a difference in datum, the piece gets placed far away. So the first thing you need to do is center it so that the piece comes to the closest possible position. After that, the height right now, the piece we have which we imported into the model has a height of 10 millimeters. If you want to adjust this height as you wish, see, if I fix its height from here and set it to a certain value, then the other values like the X value all become smaller as well. So I don't want to do that. I'll keep it here and then uncheck it. The option to lock the XYZ ratio, what this does is, now I can change any of the 3 values. So instead, if I set this to 8 and apply it, you'll notice a visible difference here on top. It has changed its thickness. After that, since we set it to center, as the center said, the 0 plane position in the day model. What will be the position of the 0 plane in the model? So I tell him, full bottom, meaning this 0 plane will move to the bottom of our 3D model. So how much will that be? Our 3D model is set with a height of 8 millimeters and the 0 plane will be positioned at its bottom. If you look here, it will be clearer to you. Look at this. This line here is the bottom line, which is the bottom plane of the model. So if I set it to the middle, the design will also go below it. Now it's in the middle. If I set it here, then this design will be completely below this plane. So I need to keep this design at the very top of the plane so that the plane acts as 0 and all the cutting happens above it. So up to this point, and here below, there is an OK option. I'll just click OK here. As soon as you click OK, this view will appear in front of you. Now you can easily work on this view. What do you need to do here? The work you have to do is to program on top of it. I won't be explaining the programming settings to you just yet, but I will show you the general tools and their dialogues so that you can work on this. As for the plunge rate and the feed rate, there will be a proper lecture dedicated to that, in which I'll describe each thing in detail. I have been observing these things in the market. People have just memorized these toolpaths by rote, as they say in Punjabi. Usually people just move on daily. But here I will do the carving with the finishing tool. Normally it's roughing first, but here I am using the 3D finishing tool because the thickness is 7 or 8 millimeters. We don't really need roughing here because if you see, normally people just write down or memorize these values. But I'm not someone who does things that way. God willing, I will in fact properly and logically brief you on all these things step by step. But God willing, when it comes to the next selection, I'll give you a general overview. The thickness is 25 and its datum X has now come onto this page here. You can also see it here. After that, its zero position is at the top. The material that we have to cut will be on the side. Look, if I move it here, you can see that the material has gone down. Then on top of that, there is an additional 7 millimeters less, which is the material gap of the middle. You will also have to cut this. So just let it stay at 0. These are the report Z gaps above the material that you have here. Just leave them as they are. For the home position, set how many millimeters it should go up, keep it at least 35. Whenever it goes to the home position, set it accordingly. As soon as you click OK, the very first thing you need to do is select the tool. When you select the tool, I have set a 0.5 millimeter diameter engraving tool here, which has a 5-degree angle. That is, the angle written here, I have set it to 5. This diameter here is basically the diameter of the column, and its flat diameter is set to 0.5 by me. We use an even smaller one when we need very fine quality 3D work. The tool you see installed here is a common Chinese tool available in the market. But if you set the degree here as I have 5 degrees, meaning from here, it will form a 5-degree angle up to this point, then it becomes just like a nail-shaped tool. So for this, use a carbide tool. If you encounter any problems with the tool or you can't find the tool in your area, do let me know. Hopefully, I will try my best, God willing, to provide you with this tool at reasonable prices so that there is no obstacle in your work. Because you are investing your time, you are putting in effort, using your energy, and you have set up the machine as well. So if the quality suffers just because of tooling, that wouldn't feel right. As for the step over, clearance, pass over, spindle speed, feed, plunge rate, all these things, God willing, will be our next topic. I will try, God willing, to explain each thing to you in detail and brief you properly. So for now, I will just play it as it is and move on. The tool has been selected. Now you need to select its boundary from here. Because if I do it this way, it will cut all the way to the outside. But what we need is to save material on the left. So it should come to the material boundary and keep it on raster as well. Click. It will take a little time to calculate, so please be patient. So viewers, I have completed this 100%. When I preview it, please notice one thing. All the machining it has done, it only did in the area where the 3D object exists. I also wanted to remove these other areas, so now I'm going to show you the easiest way to do that. Here's how you do it. Switch to the 2D view. In the 2D view, turn off the tool paths, and instead of going to modeling, go to drawing. In drawing, you need to select the rectangle tool. Place it at this edge and extend it up to here, but only up to this edge. Draw a rectangle and center it, as I've done. If there's a slight difference, it's no problem, there's nothing to worry about. You can also make it a bit smaller if you want. Basically, we are using this rectangle to create a base underneath. After that, you need to go to the modeling section. The very first tool we have is the shape tool. Select the shape tool. Now this object is also selected. I'll switch to the third view, and here I'll give it a minus 0.5 on the base side. Since this is a plane, we have a flat profile. You've given it minus 0.5 on the base side, meaning it extends downward from this design by minus 0.5. Apply this and close it. Notice that it's now attached underneath. But the one we placed underneath has extended all the way out. We actually want it to stay inside. So let's switch to 2D view, and here I'll draw an arc. I've taken the arc and now I'll trim it. As soon as I trim it, I'll delete this last component here. Now once again, select this 2D line, switch to the third model view, use the shape tool here and apply the same value as before. Now notice that a base has been added inside it. Close this and return to the programming section. Go to toolpath. On the toolpath, select the last 3D finish tool you used, select that tool and close it. Select this tool and click on recalculate. When you recalculate, it will also finish the bottom surface along with it. Since the toolpath is quite extensive, it will take a little time. So viewers, the toolpath recalculation is almost done. Here, the toolpath has been successfully recalculated, and as you can see, the path has been generated over the entire surface. Go to preview. I'll reset the preview, and here look at this. I'll preview it. Now it has started removing material from the bottom as well. So viewers, this is how we imported an STL file into Aspire, and then we programmed it. After programming, we viewed its preview. I hope that in today's session, in this tutorial, you learned a lot of new things. Please remember me in your prayers. God willing, we'll meet again with new techniques and new experiences. Allah Hafiz.